Welcome to Kanerika's podcast, The Digital Shift. Imagine handing a junior developer the keys to your entire cloud infrastructure.
Oh, that is always a terrifying thought.
Right. You assume they are just going to build a few data pipelines, but then a month later you realize you effectively handed them an unlimited corporate credit card.
Yeah, and we see that happening everywhere right now.
Exactly. That exact scenario is playing out across the enterprise technology landscape. And it really points to this fascinating, almost silent crisis. Every major organization is mapping out these incredibly ambitious data roadmaps, right?
Yeah.
Especially with the massive surge in artificial intelligence.
Oh, absolutely. Everyone wants AI right now.
But they are all running headfirst into the exact same bottleneck.
Yeah.
There's this industry-wide scramble for a very highly specific type of talent. And the reality is that most companies simply do not know how to accurately identify, let alone actually hire the right people for the job.
It really is a profound bottleneck. And you are completely right to frame it as a crisis. It is entirely reshaping how organizations are forced to build their infrastructure.
So what is the root cause here? Why the sudden bottleneck?
Well, what we are seeing is that the rapid shift from legacy systems like those traditional Hadoop environments or, conventional rigid data warehouses to the modern Lakehouse architecture just happened exponentially faster than the talent market could adapt.
So the tech just outran the people.
Exactly.
Yeah.
The technology simply outpaced the workforce's ability to master it. I mean, organizations bought the Ferrari, but they're still trying to hire mechanics who only know how to work on sedans.
That is a great analogy, and that is exactly what we are going to fix for you today in this deep dive. Our mission here is to unpack exactly why true Databricks developers are so exceedingly scarce.
Yeah, and we need to clearly distinguish them from generic data engineers.
Right. We are going to map out the critical 2026 skills required to actually power enterprise AI. And most importantly, we will provide you with a strategic playbook for how you can successfully staff and scale your data platforms without completely burning through your IT budget.
Establishing that baseline is just crucial. If you are an enterprise leader listening to this, you know you need actionable strategies.
Definitely.
You really need to understand the real-world cost implications of your hiring decisions and how to intelligently navigate this acute talent supply problem. Because right now, the definition of a data engineer has heavily fractured in the market.
Fractured how?
Well, if you do not understand the fault lines, you will just hire the wrong profile entirely.
Let's explore those fault lines then, because the Gartner 2026 Talent Acquisition Outlook explicitly highlights AI-driven skills demand and also cost pressures as the top two forces reshaping technical hiring.
Yeah, and platform-specific data engineering sits squarely in the crosshairs of those two forces.
Exactly. So for the leaders trying to staff these teams, help us understand the landscape. How is a Databricks developer fundamentally different from, say, a generic data engineer or a data scientist?
So if we look at the broader ecosystem, a generic data engineer might be highly skilled at moving data across any random stack. They use standard SQL, they write some Python, they manage basic orchestration tools.
They're basically generalists.
Right. They are generalists. A data scientist, on the other hand, is focused on modeling, algorithms and statistical analysis.
Okay, so where does the Databricks developer fit in?
A Databricks developer is a highly specialized platform engineer. They are the ones who build, tune, and govern data pipelines specifically and natively on the Lakehouse platform.
So they are deep in the weeds of that specific environment.
Exactly. They are operating the underlying mechanics of Delta Lake, managing complex Databricks workflows, and structuring the entire environment so that the scientists and analysts can actually do their jobs.
Without the whole system just crashing on them?
Yeah, without the system crashing, which happens a lot more than you would think.
I have to stop you there, though, because I can hear hiring managers asking this right now. Apache Spark, which underlies this whole ecosystem, is an open source framework, right? It is literally everywhere.
Yes, yeah.
So why can't I just take my best, most competent Spark backend developer, give them a week to read the Databricks documentation, and let them loose on my infrastructure?
That is probably the single most common assumption out there. And it is exactly how companies end up with catastrophic cloud bills.
Oh, really? Just from assuming Spark is Spark?
Yeah. Think of it this way. Spark is just the processing engine. It is the motor. But Databricks is the entire vehicle. It is the transmission, the onboard computers, the aerodynamics.
Oh, I see.
A candidate might be excellent at writing open source Spark code to process a batch of data. But if they've never touched Delta Lake optimization or, if they have no idea how to configure Unity Catalog for cross-workspace governance, they're going to struggle immensely.
Especially in a highly regulated production environment.
Exactly. The required skill set has just evolved far beyond writing a functional Spark job.
It sounds like hiring a general practitioner to perform open heart surgery. I mean, sure, they both went to medical school, they both understand human anatomy.
Right.
But you really want the person who has done 1,000 valve replacements when your chest is open on the table. And there is a massive seniority spectrum there, too. A junior developer with, say, 0 to 2 years of experience is completely different from a lead architect.
Oh, absolutely. Night and day. A junior developer is generally handling well-defined pipelines. You give them a specification, they write the PySpark code, and they maintain existing workflows.
To keep the lights on.
Right. But an architect, someone with 8 or more years of dedicated platform experience, they own the macro-level Lakehouse architecture.
What does that entail, practically?
Well, they are setting the medallion design patterns. They are managing cross-team governance and making foundational decisions about how raw data is ingested, cleaned, and secured.
And this is across, 40 or 50 different enterprise source systems sometimes?
Easily. Sometimes more. You would never put a junior engineer in charge of that foundational architecture. It just guarantees expensive, painful rework down the line.
So if generic Spark knowledge is no longer enough to drive this vehicle, what exactly does the manual look like today? What are the absolute must-have skills a developer needs to build this infrastructure in 2026?
First and foremost, you need deep, verifiable proficiency in Delta Lake. And I do not mean just knowing what it is. I mean really understanding the mechanics of ASE transactions.
Let's break that down for the listener. When we talk about SE transactions in this context, what does that actually mean for the business?
It guarantees data integrity.
Right.
Imagine you have a massive table of financial records. You might have one process writing new transactions to that table, right?
Okay, yeah.
While concurrently, a reporting dashboard is reading from it, and a machine learning model is updating historical records.
That sounds like a recipe for a traffic jam.
It is. Without ACID transactions, those concurrent operations can collide, and that results in corrupted data or phantom reads. An expert understands how Delta Lake manages that concurrency safely.
That is critical.
Furthermore, they need to understand exactly how to use optimized commands and Z-ordering.
Z-ordering is one of those terms that gets thrown around in resumes a lot. How does that physically work to speed up the system?
Z-ordering physically clusters related information together on the cloud storage disk. So if your business users constantly query data by, say, date and geographic region, an expert will Z-order the data along those dimensions.
What happens when they do that?
When a query runs, the processing engine does not have to scan millions of files. It physically skips 90% of the data on the disk because it knows exactly where the relevant information is located.
Oh, wow. It is the difference between searching a massive library book by book versus having a highly indexed catalog?
Exactly. It saves an incredible amount of time and compute cost.
That makes perfect sense. And the second core skill?
Fluency in the medallion architecture.
Yeah.
This is entirely non-negotiable.
We are talking about the bronze, silver, and gold layers. How should an enterprise be thinking about that separation?
Think of bronze as the raw, unfiltered, chaotic feed directly from every application and database you run.
Yeah.
You keep it exactly as it arrived.
Just a total data dump.
Right. Then silver is your curated layer. This is where the developer enforces structure. They are filtering out corrupt records, deduplicating, and standardizing formats.
Making it actually usable.
Yeah. And then gold is your pristine, highly refined business-level aggregates. This is what the CEO's dashboard runs on.
So a true Databricks developer knows exactly how to transition massive data sets seamlessly through those states.
Yes, and efficiently, without losing lineage. And that brings us to the third core skill, deep, practical knowledge of Unity Catalog.
This is the centralized governance layer.
Exactly. You need fine-grained access control and precise data lineage tracking across all your workspaces. It is essential to ensure compliance and security.
Here's where I see the landscape shifting dramatically, though. It isn't just about those traditional data pipelines anymore. The new generative AI stack requirements are pushing this complexity even further, aren't they?
Oh, without a doubt. A modern developer now needs working knowledge of Mosaic AI, vector search, and AI functions.
They have to support AG, retrieval augmented generation, and highly complex agentic workloads.
They do. It is becoming the standard.
But let me challenge the timing here. If you are a traditional enterprise, Are these AI skills strictly necessary right now? Or is this just a futuristic nice to have that candidates use to inflate their salary expectations?
It is a very fair question. But the reality is, it is no longer a futuristic nice to have. It is current baseline infrastructure.
Really?
Baseline, yes. Because if you are building a modern data platform today, the business side will inevitably demand AI capabilities tomorrow. They're going to want to chat with their enterprise data.
Right. Everyone wants a chatbot for their internal documents now.
Exactly. And if your foundational architecture cannot support vector search, or if it cannot seamlessly handle RJG integrations where an AI model securely queries your proprietary data, you will literally have to tear the foundation down and rebuild it.
That sounds like a massive waste of money.
It is. You must hire developers who understand how large language model workloads run natively on a lakehouse.
We see the impact of these exact requirements firsthand
Hmm.
because we at Kanerika, we operate as a certified Databricks consulting partner, designing and migrating Lakehouse environments daily.
Yeah, you guys are right in the trenches with this.
We really are. In fact, we recently stepped in to help a sales intelligence team that was struggling with incredibly slow ingestion pipelines. Their data was completely bottlenecked, taking days to process.
Days. That is brutal for a sales team.
It was paralyzing them. But by applying these specific modern architecture principles, optimizing their delta tables and restructuring their medallion flow, we at Kanerika successfully cut their document processing time by an incredible 80%.
80% is massive.
It completely transformed a multi-day backlog into a real-time, same-day process.
And that kind of immediate business efficiency is only possible with highly specialized, deeply technical knowledge, which is exactly why validating these skills during the hiring process is so critical.
Let's talk about that validation. You see a lot of candidates flaunting the data engineer associate or professional badges on their profiles, right? Or the shiny new Gen AI engineer certification. Are hiring managers falling into a trap by relying on these badges?
Well, I wouldn't call it a trap, but it is merely a filter.
Just a baseline filter.
Yeah. Certifications are highly useful for establishing a theoretical baseline. They prove that someone studied the Databricks material, they understand the vocabulary, and they know the concepts.
But it doesn't mean they can execute.
Exactly. A badge does not prove that a candidate can handle a high-pressure production crisis at 2 in the morning. It does not prove they have the production scar tissue required to navigate a failing enterprise system when millions of dollars are on the line.
That is the perfect pivot. What exactly does a crisis look like? Because understanding these advanced skills reveals exactly what goes wrong when those skills are absent in your team. Let's talk about the production nightmares.
Yeah, okay, let's get into it.
What are the specific challenges that only the seasoned pros know how to handle? The true hidden costs of underqualifying your hires.
One of the most classic, devastating examples is a skewed join.
Okay, walk me through that.
Let's say you have a massive data set and you were trying to join two tables together. But one particular key, maybe a null value or a default string like unknown, is vastly overrepresented in your data.
So you have millions of rows that all share that exact same unknown label.
Exactly. Now, Spark is a distributed engine, meaning it tries to divide the work evenly across a cluster of computers.
Right, to speed things up.
But because all those unknown values have to be processed together, Spark hands that massive chunk of data to one single node.
Oh, I see where this is going.
Yeah. So 99 nodes in your cluster finish their tiny chunks in 3 seconds, and then they sit perfectly idle. Meanwhile, that one overloaded node struggles for 3 hours trying to process millions of rows by itself.
That is a nightmare. What does a novice do in that situation?
A novice developer will see the job running slow and just provision more memory or a bigger cluster, which completely fails to fix the actual problem. It just costs more money.
So how does the expert fix it?
An expert recognizes the symptom immediately in the Spark user interface. They know to implement a technique called salting.
Salting.
Yeah, they append random numbers to that overloaded key, which tricks the system into splitting that massive chunk of data evenly across all the nodes, clearing the traffic jam instantly. Or they know how to broadcast the smaller table to all nodes to bypass the shuffle entirely.
That is brilliant. And then there is the partition strategy failure, right? If you are listening to this and you've seen your cloud compute bill inexplicably double, this is exactly what you should be looking for.
The infamous small files problem.
Yes, the small files problem. How does that happen?
It happens when a developer over-partitions their data, usually by something way too granular, like an exact timestamp. Every time data is written, it creates a tiny new file on the disk.
So you just end up with clutter.
Endless clutter. Before long, you have millions of 1 kilobyte files. Distributed systems like Spark thrive on reading large, contiguous blocks of data. If you have millions of tiny files, the system completely chokes on the metadata operations.
It is spending all its time just trying to find the files.
Exactly. It spends more time figuring out where the files are located than it does actually processing the data inside them. It is like trying to read a novel where every single word is printed on a separate page. Every downstream read slows to an absolute crawl.
Add that to delta table optimization drift, where tables quietly degrade in query performance over months because they aren't being properly vacuumed, and you have a huge issue.
And don't forget streaming pipeline failures, where jobs just drop data silently after restart.
It is just a recipe for disaster. So what does it all mean financially? Because we are looking at typical U.S. salary ranges from $100,000 to $140,000 for junior profiles.
And that scales up significantly for seniors.
Right, up to $190,000 to $260,000 or more for senior architects. Obviously, offshore rates can be 40 to 70% lower, but that base salary is just the tip of the iceberg, isn't it?
The base salary is almost irrelevant compared to the hidden costs. That is where enterprises truly bleed capital.
Where's that money going?
First, you have an 8 to 16-week recruiting timeline just to locate a qualified candidate. Then you have extensive onboarding periods. But the most dangerous hidden cost is the massive risk of cluster cost overruns.
Like the idle clusters.
Yes, misconfigured auto-scaling, or idle clusters that fail to auto-suspend because a junior developer left a notebook attached, can quietly double a cloud bill in a matter of weeks.
Going back to our earlier analogy, opting for a cheaper junior resource who likes those cost optimization instincts is essentially handing them an unlimited corporate credit card for cloud compute.
That is exactly what it is.
The financial logic of enterprise hiring often breaks down right here. You might save $30,000 on a salary by hiring a junior generalist, but you subsequently burn $80,000 in entirely avoidable cloud compute costs because your Spark jobs are running horribly inefficiently.
That is the exact mathematical reality. The sticker price of a resume rarely reflects the total cost of ownership of the employee.
Poor performance tuning just erases any upfront salary savings within the first quarter.
Almost instantly.
Since the cost of getting this wrong is incredibly high, both in literal cloud spend and project delays, we have to pivot to the tactical solution.
How do you actually fix this?
Exactly. How do you strategically engage and aggressively vet this level of talent? Let's talk about the different hiring models available based on a platform's maturity.
Well, it is entirely dependent on your timeline and your current platform maturity.
Let's start with full-time.
Full-time hiring is best for long-term platform ownership and institutional knowledge. But as we noted, it is incredibly slow to execute.
And freelance?
Freelance hiring is fast, but the institutional knowledge walks out the door the moment their contract ends.
Which leaves you vulnerable.
Exactly. Then you have staff augmentation, which gives you incredibly fast, platform-specific capacity with predictable usage-based costs. And finally, dedicated or managed teams.
When would you use a managed team?
They are ideal for massive undertakings like full migrations off legacy data warehouses where you need high-level architecture and rigorous execution pulled together.
I have to use a rent versus own analogy here because this really trips up a lot of executives. Building a new lakehouse feels a lot like building a modern skyscraper.
That is a very good way to put it.
You need a massive, highly skilled crew to pour the complex foundation, erect the steel, and wire the sophisticated electronics. But once the skyscraper is built, you do not keep 100 construction workers on payroll just to change the light bulbs and mop the floors.
No, you absolutely don't.
So why do so many enterprises default to wanting to own all this specialized talent full-time instead of renting the heavy hitters for the build phase?
It is a legacy mindset, really. And it severely damages strategic agility during peak build phases. When you are migrating from a legacy Hadoop system or building a new lakehouse from scratch, the volume of complex architectural work is immense.
It is an all-hands-on-deck situation.
Right. But once the platform reaches a steady governed state, the required headcount drops significantly.
So if you hire them all full-time, what happens?
If you strictly mandate full-time hires for the build, you end up permanently overstaffed, paying top-tier architectural salaries for routine maintenance.
That makes total sense.
Staff augmentation allows you to inject heavy-hitting expertise immediately, complete the complex build correctly the first time, and then scale back smoothly. It removes the 16-week hiring delay and ensures you have certified professionals writing optimized code from day one.
Regardless of whether you build full-time or use staff augmentation, the vetting process has to be rigorous. You cannot just ask generic big data questions from a downloaded interview guide.
No, that will get you nowhere.
So how do you actually filter for true platform-specific competence?
You skip the buzzwords entirely. You go straight to architectural judgment and live troubleshooting scenarios.
What's that look like in an interview?
For an architect, you ask them to physically sketch a medallion architecture for an enterprise with 40-plus distinct source systems. You want to see their thought process on separating the bronze, silver, and gold layers.
You want to see them actually solve the problem.
Exactly. You ask them, how do you handle schema drift when a source system suddenly adds 3 new columns? How do you structure the Unity catalog permissions so the marketing team cannot see HR's payroll data?
And there is that great interview test regarding job failures that really separates the experts from the novices.
Oh, yes.
My favorite. You pose a simple scenario. You say, a Spark job that normally takes 20 minutes to run suddenly takes 3 hours today. Walk me through exactly how you investigate it.
Yes, that is the ultimate litmus test for production experience. If their first answer is, I would allocate more memory to the cluster, you politely end the interview and pass on them.
Because they just want to throw money at the problem.
Exactly. You are looking for answers that demonstrate a deep understanding of distributed computing mechanics. You want them to mention investigating driver-side data collection, checking if someone accidentally pulled millions of rows into the driver node.
Which would just crash it.
Right. You want them to check for oversized broadcast joins, or explain exactly how they would dig into the Spark UI to analyze the stage execution times and identify straggler tasks.
They really need to prove they know how to read the diagnostic monitors, not just hit the gas pedal harder. Building a truly AI-ready data foundation isn't a generic IT project. It requires uncompromising, specific Databricks expertise.
That is the absolute truth.
If you rely on generalists to build specialized Lakehouse environments, you are almost guaranteeing performance bottlenecks, frustrated data scientists, and massive cost overruns.
And that is exactly where having the right execution partner changes the equation for an enterprise.
Exactly.
Whether you are looking for agile staff augmentation to speed up a current build, a comprehensive AI maturity assessment to see if you are really ready for Gen AI, or a full end-to-end platform migration, we at Kanerika possess both the architectural vision and the execution capabilities required.
And we extract tremendous insights from the field data. For example, we at Kanerika recently utilized our specialized expertise to help a major healthcare organization migrate their entire infrastructure from legacy Informatica directly to Databricks.
That is a massive undertaking.
It was. But by redesigning their pipelines around Delta Lake and enforcing governed Unity catalog access, we improved their enterprise reporting accuracy by 71%, and we accelerated their decision speed by 64%.
Those are the kinds of metrics that fundamentally change how a business operates. They stop fighting their infrastructure and start utilizing their data.
Well said. I want to leave you with a final, lingering question to ponder as you map out your own organization's ambitious AI future. Look critically at your current setup.
Really take a hard look.
If your data governance is scattered across varying, disconnected workspaces, and your hiring strategy currently relies on outdated big data buzzwords rather than verified, highly specific architectural judgment, are you actually building a resilient foundation for artificial intelligence, or are you just building a faster, exponentially more expensive legacy system?